let's talk a little bit about shore power and what we have to do. With my boat, we have just a simple battery, no charger, nothing on it. And I want to change a couple of things. Changing means I need definitely a charger. The charger requires 230 volts. Maybe in US it's a little different because we have countries with 230 and we have countries with 110 volt. Literally, both is the same. One thing very upfront, and that's critical and super important if you do not reflect this one and take care about it. Working with 230 volts actually is not undangerous. So either way, it is dangerous. If you don't know what to do, just get someone who has the proper education. Myself personally, beside of studies and everything else, I just have even the German education in everything around electrical engineerings. I worked even up to 110,000 volts down to all the electronics, even with fiber optics. That's why I said I can do it myself. Nevertheless, if you touch the public circuit, the public power circuit, you need to be certified. That means if you do something on public, which is connected to public, you need to have someone who certifies your 230 volt installation. That's very important and you always need to keep this in mind. Let me show you what we need first. I'm going to draw a little bit. So if we have the shore power, like we have anyhow here 230 volts, which are actually going into your boat. So that should be my boat. So just put the sail on that you know what it is. We need to cable it from here to here because we have chargers in here. We have other whatever we want to just plug in, like for example, you have a heater or whatever. We need, for example, a heater. That's why we do it beside of the charger. Two things are super important. First part is you need to have certified devices. I use like this device from Victron Energy, and that's a shore power device made for European. You have those connectors, and in US again, or even in some other countries, it looks probably a little different, but since we are in Europe, I use this. That's the first part, which is important, and it needs to be watertight. That's very important here. So there are some rubber and we can close this proper. Inside it's also then properly protected. I have that laying anywhere else, but that's what we install outside of the boat. That's also important because of it needs to be really watertight. And I haven't actually found it on site here, but it's an IP67, so that needs to be waterproof and very watertight, and it also needs to be resistant against dirt. That's the first part. The other thing you need, if you cable within or inside of your boat, you need to have a proper cable. There are always legal requirements, like even in Europe we use, or even in Germany we use the VDE requirements, and you need a special cable. Like I use this for 230 volts inside of your boats. It's an H07BW/F cable. It has, as you hopefully can, yes, you can see it here inside. It has blue, which is neutral. It has brown, which is actually having the potential. And we have the green-yellow, which is the ground. With those things, we are actually good to go. Same, by the way, if you use this cable, that's also required. It needs to be water and it needs to be chemical/oil resistant. If you just cable from the shore power plug on your boat to the shore power plug, which is on your shipyard. Beside this, we want to be protected. So when we go here and say that's what we actually want to design, then I need to see, I have anyhow here my shore power. I short this a little bit, and we have the cable which is then going to the boat. Most likely here inside, where we have the plug connected, we should have fuses very important. Since this one runs only on one phase, we also have three phase. Three phase means like 400 volts. We are not talking about this today because probably one phase with maximum of 16 amps is still fine. So we have the 16 amps. What should be here inside is a fuse. And for sure what we should have inside here is the residual current circuit breaker. But it's always, also in German we call it FI, that's always a question if it's there or not. If it's not there, you risk your life. Let me quickly explain what has happened. If you actually touch the 230 volts by accident, or even you have anywhere a leakage and you touch some metal which is carrying nearly the 230 volts, I show you what is going to happen. We have with our current powers, we have here it's 60 Hz, and in US probably we have 50 Hz. So just that you know this. And so it's oscillating. If you touch it, and since it's oscillating with a frequency of 60 Hz, it causes problems directly on your heart. It's not like if you have the DC. DC is not that weird. You just stuck in it and die slowly. If you touch 230 volts, that goes much more faster because your heart, it's pumping differently. So it flickers, and this flickering actually causes your heart getting out of the rhythm. And that's why you would actually die. Not always, but that's why we need this residual currents circuit breakers here. Since, as I said, we don't know if this breaker is actually really on the shore power side, which is on your shipyard, you need to install it on your boat too. That means, again, maybe just in between, because before somebody talks about it, when I talk about it, the danger of electricity, it is not the voltage which cause problems or harm to your body. It's always the current. So if you touch 230 volts, but there is no current, nothing is going to be happening. Like, you know this one, you rub a balloon and you put it on, okay, I don't have hairs, but you put it on someone's head close to the hairs, you know, they stand up. This is just something electrical. I don't want to explain it right now. But what you also figure out is if you touch someone, you see a tiny spark. And if you have a spark, there is huge voltage involved. You see this probably on some other generators where you can create very high voltages, but the current is extremely low. So the current is actually the dangerous thing. Current means some electrons flow through your body, and that's dissolving your blood. That's why it's very, very dangerous. Maybe, I don't know if you can see it here, so there are still some dots, and I was hit by around 700 volts. Yeah, the current was still very low, but actually there is now a channel for the rest of my life. That's why you should take care. I've forgotten something when I worked on some laser installations. But that's important. 12 volt does not mean it's not dangerous. 230 volt does not mean it's dangerous, but since we have huge currents behind it, the current is actually the thing you should care. And when we have the AC power, since it's like a wave, I'm going to plus, minus, pretty fast. It interacts with your heartbeat, and that causes your heart getting out of the rhythm. That's why electrical energy is super dangerous, and you should always think about it. Okay, let's talk about and continue here. As I said, on the boat side, we need also to secure the electrical installation which we have. So what do we need? The fuse and the residual current circuit breaker. Let me show you how that looks like, and then I show you what you do. Sure, everything you would have to cover also in a waterproofed and dirt-proofed chassis. That one, it's IP65, so IP65, one stands for water, the other one stands for the dirt which could actually get in, and that's what actually coming onto the boat. Good, let me show you what is what on our side here. So, and I guess you should be probably aware, this is a very normal fuse. This fuse protects up to 16 amps on the 230 volt side. So that's one part. The other part is actually here. I hope I can get it out, because if not, I show it this way. No, and because I clipped it and I don't have my screwdrivers. But you should probably see it. This is the really life-saving part on it. And what we see here, it reacts if there is a misleading current. Misleading means like a current which is not coming in from the power phase through the neutral phase, but some current runs through the ground, so, or PE. And that one is here is 0.03 amps, 30 milliamps. So that's again, I show you, we actually need to restrict the maximum current running through our body. That's protecting. What is actually not written on here is how fast it reacts, but that's always a legal requirement, how fast it can react, and sure, they confirm, so that means most likely is within 1 amplitude, so that nothing actually to your heart will be happen. So that means looking at on a boat, again, here is our shore power connector on the shipyard. Now we cable it, and here on the boat side, we just put in two things, which is on one part here is the residual current circuit breaker, and here is the normal fuse. So what ranking, how do we get in? There are requirements. Yes, actually it doesn't matter because whatever comes first comes first. But I always recommend getting, I use the German shortcut FI first, and then the fuse on the second. How is this actually cabled? Also not very, very difficult. We have 3 ADs in it. We have like L, or other one say P. We have N for neutral, German neutral, and we have the PE, which is actually the ground. So just make it like that, and that you can know how it looks like. Then we go into our FI. I use the shortcut German because then I only need to have 2 letters. On the next side, we put our normal fuse, and from here we put our switchboard. Switchboard. And then you can distribute to wherever you want. Now we put also the PE, and that's important. So I extend our switchboard because the PE is the same thing, you ground it, and then you can distribute it to all devices which you need to power with 230 volts. And now something really has happened that we also need to take care. As you see, again, here's our boat. This is the boat, and this is the shore power device I shipped. And here we have water in between. And now I show you what is actually going to be happening. Let me just do it, and I cover it with my hand first. I hope that's visible. I can zoom in. So we have LN and PE, and we connect it to the boat. Since now we have the ground, the PE, connected to our boat, and also we have it connected on the shore power side. And in between here, where you have the arrows, there we can have potential differences, and the potential. That means energy, or electricity in this case, can flow over the PE back through the water, and that could cause corrosion on your boat. So now it's a good question, can that happen as well if you have a GFK boat. So with fiber optics and everything. The fiber, yeah, yes, no, no, yes. Okay, let me explain what would be happen. There is an engine. If you have an engine and the engine has even a generator or is anyhow connected to anything, which is actually here to the ground, to the PE, then yes. That means not only on a motorboat where you definitely had it, or even if the chassis here, if this chassis is like steel or aluminium, this will be happen. It will be definitely, it will be happen on different parts. Okay, why? First is we can have sweet water, which still isolates, but not that good compared to any other material like plastic, for example. On the other hand, we could have salty water. Salty water has, yeah, as the name says, it has salt in it. Salty water with the ions inside make the transport of electrons even more easier. So that means like, yes, we need to do something. That's why there are options. What options do we have? One option is drawn in this picture. That means like, what means this? We need to implement galvanic isolation. That means that everything on the energy side is totally separate. It has not the same potential anymore, because if it's not connected, it do not have the same potential. That's a very important part. How can we do this? That's called an isolating transformator. We can use this. So our boat here, you will see it's still connected with the same PE, but actually the possible flow of current, which actually makes your boat corroding, is therefore terminated. That's good. Of course, there is no potential difference, so in this case, it is both the same. That's one option. The isolating transformator is pretty expensive. There are other possibilities because it needs to carry or transform the same power. Like if you are using, say, 2000 watts, which can be happen with a heater, that needs to be a transformator here, which can carry at least a little more than 2000 watts. That's it. And again, it just stops all that current leakage, which could be happening here. So oxidation, corrosion, it's not what we want to have. I have drawn a different option. Look at this option. It's again, we have the same potential, but anyway, we need to break. We need to break in between here. What we have as a second option is to set a so-called galvanic isolator. The galvanic isolator acts with a diode inside. So this is somehow something let currents flow only through one direction, not the other. That isolates it as well, because the potential difference which needs to be overcome that a current can flow, this diode can actually block. You know this, an LED is a diode, and you need to put in more energy that it flows. And this isolator, it's a cheaper possibility probably than the isolating transformator. The isolating diode or galvanic isolator is one of the options you can actually have. What might be necessary? Again, not on a GFK boat, but definitely necessary if you build this construct, or even if you build it again with an isolating transformator, is somehow something like the so-called oxidation diet. So like a sacrificial anode, which you need to put. That most likely you see on some boats are here. So you bring it in, it's made from zinc, or you have sometimes you have it even next to the propeller. That is actually good. And let me explain what will be happen here. So There is an electromechanical functional principle behind it. And that means like if metal is in touch with water or somehow humid environments, it will be attacked. That has to do something with flowing or with using this electrolyte thing. You have, for example, inside of a battery, the same principle. There are some anodes. You have the battery water inside. Lithium ions work a little different, but like with the basic principles, and it creates potential first. Only if you close the circuit, like say you have plus and minus, so then you close the circuit, only then based on the potential, the electrons can flow, and that actually is called circuit. And now we need to just make it happen that there, and this is actually the sacrificial anode doing, it is on the flow of current faster, and it has lower resistance compared, for example, to aluminium or steel or anything else. So that means like energy flows most likely there where the lowest resistance is, and that will be the sacrificial anode for you. That's the principle you need to know if you build shore power on your boat. In the next video, I show you how to install it. That will be probably next weekend. And I'm cabling everything. I show you where I build it. I show you how I build it, because we even have normal 230 volts power plugs in. One I'm using to plug in our battery charger, and the other one we need either for charging a laptop if we are stuck to the shipyard, or we need a heater because we're in Germany. That means like it can be pretty cold in April or May. Also in October it was very cold. Yes, we want to have a heater. So I need something, and I need to recharge our battery. I'm having no solar panels right now. That's another chapter I probably show you upon we purchase our solar panels, because I want to be really independent and super environment friendly. I hope you enjoyed this video. Don't forget to subscribe and watch the next videos while I refit and do all the electrical installation, and I explain you probably everything. Have a great day. Bye bye.